Good evening and welcome to Carl Crumry. My name is Grant McKenzie and we're going to be looking at AS level maths, where we're going to be covering simultaneous equations, circles, inequalities using the discriminant. Let me start that up. So we have the first simultaneous equation. So let me just unpin. There you go, sorry. All right, so we have simultaneous equations, and as I said, circles and the discriminant. Starting with this equation here. So simultaneous equations are normally when you have a quadratic and a straight line where they're going to cross. Okay, so this one looks very much like a circle, but it's not because the signs are different. You have a straight line, which is 2x plus y minus 5 equal to 0. And then we have a curve or parabola of some description. So it's x squared minus y squared equal to 3. It's a 5 marker and it is just simply solving. To do this, whereas you would normally have done elimination via GCSE, but now this is substitution. Okay, so you're going to try and make this one either in terms of x or y, and then you're going to substitute it into this equation here. What I would recommend is to, because y, the coefficient y is 1, I would rearrange this so that you have y equals, take the 5 over, take the 2x over, so then that's going to be plus 5 minus 2x. This function now we're going to substitute into the second one, where x squared, and then it's going to be minus 5 minus 2x all squared is equal to 3. By doing that gets you 1 mark. Okay, so you have now written the equation all in terms of one variable. If you'd have done it the other way around and put in 2x in, you're going to have halves and you're going to have 5 over 2, which is not a problem, but it's just going to make your life that little bit more awkward. You now need to expand the 5 minus 2x all squared. You can move it over to the side and expand it via a double bracket, smiley face, foil, however you would have been taught. I'm going to use smiley face. So we have that one, left eyebrow, right eyebrow, smile, and then you have a chin. So 5 5s are 25. We have then minus 2x times 5 is minus 10x. We also have another minus 10x. And we would have plus 4x squared. Simplify it down to 25 minus 20x. Plus 4x squared. Once we've done that, or the other method I like to use is, especially when it's a double bracket squared like this, square the first, that gives you the 25, square the last, that gives you the plus 4x squared, and then twice the product. Well, 5 times minus 2 is minus 10x, and then double it gives you the minus 20x. However, it doesn't make any difference. Be careful of this minus sign outside of it, because when you put it in, so if I write it as x squared minus, and then you've got now your 25 minus 20x plus 4x squared, and that is equal to 3. I don't want to see invisible brackets. I want to see the brackets there so that when you're multiplying out that minus, everything goes. X squared minus 25 plus 20x minus 4x squared, and I'm going to bring the 3 over. Minus 3 equal to 0. Tidying that all up will give you minus 3x squared. The plus 20x stays. So minus 25, so that's going to be minus 28, and that's equal to 0. Again, you can factorize that, but I just divide by minus 1, or you take it over to the other side so that you get 3x squared minus 20x plus 28. 0. Here we either need to factorize it to work out the values of x, or you could use the quadratic formula. Your AS level students, it's your decision. It hasn't told you specifically at the start of the question how you want to do it. I know that some of you still have issues with factorizing, but factorizing is the quicker method. How you do that is entirely up to you because you've all got little sort of techniques. The way in which I would sort of do it would be by trial and improvement. 3 is a prime number, so it has to be 3x and x. The 28 would be, well, there's no point doing 28 and 1. The signs have to be the same because they're both, there's a plus there, so they're either both negative or they're going to be both positive. Because of the minus sign, they're going to be obviously both negative. 14 and 2, 2 3s is 6 plus the 14, so that would work for me. So that's going to be minus 2 there, and this is equal to 0. So then I'm going to say that 3x minus 14 is equal to 0, or x minus 2. X minus 2 is equal to 0. I put a line so that you can see that it's distinguished from it. So then 3x equals 14, x equals 14 over 3, or x minus 2 is equal to 0, so x is equal to 2. If you don't factorize or use the correct formula to solve this, then if you just come out straight from here with the answers, your calculator will do that, but you won't get any marks. Okay, they're very strict on that. It has to be a method and you have to show a method for that. We still haven't quite answered the question because we've solved it in terms of x. Now we need to stick it back in to solve it for y. We have our x values and we have our y values. I'm going to change color again. So this time you're going to put y into this equation. There's no point in putting it back into the x squared minus y squared equals 3 because it's just going to make things more awkward. So we put in y equals 5 minus 2, 14 over 3. So y is equal to, you've got calculators, so you can stick this straight in. 15 divided by 3 is 5, and that is minus 28 divided by 3, which will give me an answer of 13 over 3, so y equals minus 13 over 3 is my one coordinate, and then y equals 5 minus 2 times 2, y equals 5 minus 4, which is 1. So the two coordinates that work for this would be 14 over 3 minus 13 over 3, and we got 2 and 1. Done. Job done. Right, let's see, there's another one. So I thought I'd put this one in because this is the start of question which could lead on to integration. I'm not going to do integration. If you look back at the previous column notes then on the website, then you can see column and rig that. You will see that there is a whole section on integration which you can look through yourself. I thought I'd do the obviously different sort of values, different topics, so that you've got a broader picture and you can look back over the videos from last year. So here the first question shares, so figure 2 shows part of the line with equation y equals 2x minus 3 and part of the curve C with equation y equals x squared minus 2x minus 15. The line L and the curve C intersect at the points A and B as shown. Use algebra to find the coordinates of A and the coordinates of B. So again, it's just very similar to simultaneous equations. How I would use these videos if I was you, reading the question, obviously you know now it's going to be simultaneous equations. Pause the video, try and work through it yourself, and then come back to see what the correct answer is, and then also where you've gone right or where you've gone wrong, and sort of fill it in. The beauty about this, they're both y equals, so I can equate them straight away. So I've got x squared minus 2x minus 15, and that is equal to 2x minus 3. Moving over, we then have x squared minus 2x, bring the 2x over, so it's going to be minus 4x. Minus 3 comes over, so it's going to be minus 12, and that would be equal to 0. So I'm left with x squared minus 4x minus 12. Again, I need to see a method in which you're solving this quadratic. Nothing wrong with the quadratic formula, nothing wrong with factorizing it. You can even complete the square and then sort of solve it that way, but it needs to be a method and it needs to be stated. X and x, because that's the only one that can work. Factors of, or pairs of factors of minus 12. what a minus number, minus 6 and 2. Yeah, minus 6 plus 2. X minus 6 is equal to 0. X plus 2 is 0. X equals minus 2. X equals 6. So I now have my two values for the x, which you can see that point A is obviously going to be -2 or minus 2. Point B is going to be 6. We now substitute it in to work out the y values. So y equals 2 times 6 minus 3. Y equals 12 minus 3, which is equal to 9. So this coordinate, point B, is 6, 9. And then again, y equals 2 times minus 2 minus 3. Y equals minus 4 minus 3, which is minus 7. So A is going to be looking at minus 2 minus 7. If I just quickly sort of go through the next part of this question would be, how would you work out the area of R? Okay, I'm not actually going to do that, but what I would do is show you what you would need to do. So working out R, you would also need to find out this coordinate here. And if you have a look at this, you have a right angle triangle. With that right angle triangle, you would work out the area of it. Equals half AB sine C. No, you wouldn't use that, sorry. Area equals a half base times height. The base then, you would have to work out, you've got the coordinates of B, which are 6 and 9. You'd have to find out this section here where it crosses the axes, take it away to work out the base. The height is 9, it's just going to be the y value. Working that out, and you go from there. And then you would take it away, because obviously that's the area of the triangle. You would then work out this little section in green using integration of the curve. And again, you would find out the two coordinates where x squared minus 2x minus 12, that graph where it cuts the axes, and then you've got your two limits in there. Take one away from the other, and you've got the answer. As I said, if you look back at the on the website from last year's notes, there's integration work, coordinate geometry, and differentiation at AS level, so you can then try those questions as well. I've got one more simultaneous equation for you, and then we're moving on to circles. So here again, I thought I'd make it slightly more awkward, where instead of the y's equal to each other, so the first one was, the first and third one is again sort of extra practice. The second one was more practical use of it and when it comes in. Here I would move the y over straight away, so that you're going to rewrite this as y equals 3x plus 4. Substituting that into, in this time, it is an equation of a circle, because the coefficients of x squared are the same and they're both of the same sign. Substitute that straight into the quadratic, so that we have x squared plus 3x plus 4 all squared equals 34. And again, you can see how to expand this. You can take the 3x plus 4 over to the right-hand side and expand it as a double bracket. As I said, how I would then expand it would be square the first, so 3x all squared is 9x squared. Square the last, so that's going to be plus 16, and twice the product. 3x times 4 is 12x, double it, so that's going to be 24x. And that is equal to 34. Tidying this up, we have 10x squared plus 24x. I need it equal to 0 before I can solve it. Any quadratic, as you'll see with the discriminant coming up, you must put it equal to 0 before you can then go on and solve it. Okay, so the 34 is going to come over, so that's going to be minus 34, so it'll be minus 28 minus 18 is equal to 0. So I've got my notes on the side, just to sort of remind myself. There's nothing wrong with, again, factorizing, completing the square. And last time I'm going to tell you this because you can sort of, as you can do, you do it yourself. However, I would probably divide this by 2 just to make the factorizing a little bit easier. So it's 5x squared plus 12x minus 9 equal to 0. 5 is a prime number, so it has to be 5x and x. 9, so plus and a minus. 9 and 1 is not going to help me. 3 and 3 would. 3, 3. Let's work out the sign. So I need it to be plus 12. So that's going to be 15. Take away 3. So this is going to be my plus, and this is going to be my minus, and then that's equal to 0. Again, solving it. 5x minus 3 equals 0. X plus 3 is equal to 0. X equals minus 3. 5x equals 3. X equals 3/5. We've worked out the x values. Now let's work out the y values using y. Using y equals 3x plus 4. So let's put the x one in. When x equals 3/5, y equals 3 times 5ths plus, instead of 4 there, because of the fact that the 5's on the bottom, I'm going to write that as 20 over 5. 20 divided by 5 would give you the 4. I mean, you've all got calculators, so it's not a big stretch. You just type it in. So it's 9/5 plus 20 over 5, which is 29/5. So this coordinate is 3/5, 29 over 5. Be very careful if they are asking for exact values, especially if it is like a 3 on the bottom. I mean, the 3/5 is 0.6, so I mean it's not a big deal. But if it was 1/3 and the question asked for the exact value and you wrote it as 0.3, again, unless you put the dot above the 3 to show it's recurring, I would therefore highly recommend that you leave it as a third. Fraction is probably the best way. For the other side, it's a whole number, so it's a lot easier in terms of writing it. So x is equal to minus 3. Y equals 3 times minus 3 plus 4. Y equals minus 9 plus 4, which is minus 5. So then you have minus 3 minus 5 as the other coordinate, and you're sort of done. I thought I'd put in here as well, let me change color, a sort of sneaky, what I would call a sneaky quadratic. What I mean by that is the power of the middle term, which is a quarter. If you were to double that, and that's the first term power, you could write this as a quadratic. Some examples that you could, what I mean by that would side here, examples would be, again, I'm not going to solve any of these because I'm making them up off the top of my head, so you can just see what I mean. If you had 3 y to the 6 plus 2y to the 3 minus 17 equal to 0. This could be written as quadratic. That power there, 3 is times it by 2, you get the first power. Okay, how we would then go about solving this would be, we would say, just pick another letter, MP. Let's use P is equal to y to the quarter. So you always put the P equal to the middle term power. So now that I have 2p squared minus 7p plus 3 equal to 0. And again, solve it how you would like. Primes is easier to use. 2 times 3, and then a 1, so they both have to be minus, is equal to 0. So 2p minus 1 equals 0. 2p equals 1. P equals half. Then you've got p minus 3 equal to 0. P equals 3. We haven't quite finished in terms of solving it. What we have done is we have created it in terms of p. So if we then take out the substitution, let's see what color, orange. So instead of p now, as we said up here, we've now got y. We've now got y to the power of a quarter is equal to a half, and y to the power of a quarter is equal to 3. The opposite of a quarter is to the power of 4. So y equals a half to to the power of 4, which is obviously 1 times 1 times 1, which is 1, and then 2 times 2 times 2 times 2. Probably should have got another 1, but anything. 2 to the power of 4, 2 times 2 is 4, 2 times 2 is 4, 16, so it's 1/16. And then for this one, y equals 3 to the power of 4, so y equals 3 times 3, 9, 3 times 3 is 9, 9 9 is 81, which would then solve it. For this one, which I am not going to solve, it was merely showing other examples of where this technique can be used. If you want, you could also do it in terms of other fractions. It just needs to be double the amount. So if we could have 5y to the 2/3 minus 3y to the 1/3 minus 5 equal to 0. Again, if this is times by 2, so my substitution here would be h is equal to 1/3, and then just go 5h squared minus 3h minus 5 equals 0 and solve as you will. Let's get on to circles. So here the points A and B have -8, -8, 12, 2 respectively, which just means that A is that value, B is that value. AB is the diameter of the circle, C. Find the equation for the circle C. Now, to find the equation of the circle, we need 3 elements. We need the x coordinate and the y coordinate of the center, and we need the radius. Okay. How are we going to go about those? Well, what do we know about a circle? Diameter goes from one side to the other, passing through the center. So if we've got the 2 end coordinates of the diameter, the midpoint of that is then going to give us the center of the circle. There are a school of thought, you can use a formula, you can, it's entirely up to you. You can just remember that if you add the x coordinates and divide by 2, add the y coordinates and divide by 2 to get the center, it doesn't matter. I mean, I think I'll probably sort of write it down as midpoint equals x chords divided by 2. Let's put sum of x chords down actually. Sum x chords divided by 2, sum y chords over 2. So then the midpoint is going to be -8 plus 12. So that's going to give you 4 over 2. And or the other one is -8 plus 2, which is -6 over 2. So our center is going to be 2 minus 3. Let's write that as 2 minus 3 down. Okay, so now we've got the center, we need to work out the radius. Well, we can work out the radius by, again, using the formula. Length of AB is equal to the square root of y2 minus y1 all squared plus x2 minus x1 all squared. It doesn't matter as long as you're consistent which one you're using. So I'm going to go -8 minus 2 all squared plus -8 minus 12 all squared, which will give me the square root of, that's 100. And then that's going to give you 20 squared, which is 400. So that is going to give you the square root of 500. So that would be the length of diameter. As I said, I need the radius, so I need to divide that by 2. And I'm probably going to leave it like that, okay? Because I know when I'm writing this down, I'm going to have to, especially for the equation of the circle, I'm going to have to put down the radius squared. So rather than square rooting it and trying to work it out, I'll put it in surd form, which will be 10 root 5, which then goes to 5 root 5. I'll just leave it like that, and then we'll sort it out after. The equation of the circle would be x minus the x coordinate, which is 2 all squared, y minus the y coordinate all squared equal to the radius squared so then it would be x minus 2 all squared plus y plus 3 all squared equals 500 over 4, which is the same as 125. So it hasn't specifically asked me for writing it by expanding out, so I'm not going to waste time. I'm just going to leave it as x minus 2 squared plus y plus 3 all squared equals 125. That's my equation of the circle. And then I'm going to go on to part B, part A, part B over on this side. Probably should have done the other way around. Part B is the point 48 also lies on C. So C is the circle. So we've got 48 that lies on C. I mean, sometimes it might help if you put a diagram on it to visualize it. Well, we know that center is at 2 minus 3. So then if you put it, there's the center approximately. We know 0.48, should put it up higher, is there, and we need to work out this tangent here. From circle theorems, I'm hoping you remember that the radius meeting the tangent is equal to the sort of angle is at 90 degrees. So if we work out the gradient from the center to the point C, and then if we know, which we know the perpendicular because it is, m1 times m2 is equal to -1, then we have got that gradient and then we can work out the line. I would say we have to make sure we write it in this form and we have to put it equal to 0. Okay, so where A, B, and C are, well, in this case it doesn't sort of state, but it should state that they are integers, integers being whole numbers. So the gradient is again y2 minus y1, so it's a change in y over the change in x. This time it is the center with the point C. So in this case we're going to have it as -3 minus 8 over 2 minus 4, which is -11 over -2, which is 11 over 2. So that's the gradient of between the radius and the point on C. So if we want the perpendicular gradient, it is going to be m1 times m2 equals -1. So 11 over 2, flip it and change the sign. So it's going to be 2 11ths, which is equal to -1. And then also the coordinates of our tangent are 48. Most, I think, use y equals mx plus c. So y is 8 equals -2 over 11 x, which is 4, plus c. So this is going to be -8 over 11. Take it over, so 8 can be written as 88 over 11. So 88 over 11 minus 2, so plus 8 over 11, and that's equal to c, which is 96 over 11. So c equals 96 over 11. So you can see what the answer is. So then you have y equals m, which we know as -2 over 11 x, and that is plus 96 over 11. If I times everything, because I still haven't completed, I need to times everything by 11 so that I get 11y plus 2x minus 96. That is equal to 0. Therefore, it's written in the format where a, b, and c are integers. So let me just have a quick look at time. I think I'll do one more circle, and then I'll move on to the rest of the work on discriminant, just because there are 3 questions there and they're quite hefty. So next one we have with the circle is the diagram shows circle equation x squared plus y squared minus 8x minus 6y equals 20 is equal to 0. find the center and the radius. Now, to find the center and the radius, we're going to have to put it in the format we had previously, which was x plus something squared plus y plus something squared equals a number. Also, sort of to point out, if the coefficients of x squared and y squared for a circle have to be the same, if they were equal to 3, you would reduce them down so that it was x squared and y squared on their own. Okay? You couldn't then sort of work it out until you got the coefficients of those equal to 1. How I would sort of go about doing this is I would put x squared and minus 8x together plus y squared minus 6y minus 20 equal to 0. If you remember about completing the square, you half it and minus that value squared is outside. So we've got x minus 4, half of 8 is 4, all squared, and then minus 16, because 4 squared is 16, plus y minus 3, all squared, minus 9, minus 20 equal to 0. It's almost in that format, x minus 4, all squared, plus y minus 3, all squared, and this is minus 36, plus the 9, minus 55 equal to 0, x minus 4 all squared plus y minus 3 all squared equals 55. Therefore, the center coordinates are going to be 4, 3. So you just basically change the sign of the number inside, and the radius is equal to the square root of 50, which is not going to be helpful in any way, shape or form. Which question are we on? Minus 20. That's the one. Okay, next point. Find the equation of the tangent. So the circle crosses the positive x-axis at. Sorry, find the radius and find the circle. So the radius is 4, 3, and we have circle crosses the positive x-axis at the point A. Find the equation of the tangent to the circle at A. Okay, so in doing so, it will just carry on anyway. So this is point 1. Point 2. In doing so, the only way we can work out the value of A is by putting y equal to 0. So in putting y equal to 0, I'd probably put it into the original. You could put it into that one if you want, but just the reason why I always stick it back into the original, if I've made a slight mistake or a slight error in that one, then what I can say is, if you go back to the original, that hasn't changed. So there's no problem with that. So we would then put y squared is equal y equal to 0. Sorry. So that we have x squared, and then it's going to be minus 8x minus 20 equal to 0, which will give us, factorizing it again, x 4 and 5. No, I want minus 10 and 2. 2. Then this is going to be a minus 10 because I want minus 8 plus 2. So I've got x plus 2 equals 0, x minus 10, x minus 10 is equal to 0, x equals minus 2, which is obviously this part over here, and x equal to 10, which is this part here. So so we know that this coordinates is 10, 0. We just worked that out, and it says find the equation of the tangent at A. In doing so, you would work out from the center, which is 4, 3, work out the gradient of it. Once you've worked out the gradient of it, you would then flip it, and because it's the radius meets at different lines. Sorry, the radius and the tangent meet at 90-degree angles, so m1 times m2 equals -1. And then it's the same as before. I will fill in the rest of this question. The reason why I want to move on is because we've got 10 minutes left, and I'd like to do the discriminant as well. So when you, obviously it's not in the video at the moment, but when you look it up for resources, the rest of this question would be filled in. But I do want to move on to, and I'll also do that one. And that one. Obviously put a little bit too much work in. So if we can go through this discriminant. So we have the equation k, open brackets, 3x squared plus 8x plus 9, close brackets, equal to 2 minus 6x, where k is a constant value and has no real roots. So that equation, k is constant and real and has no real roots, show that k satisfies that inequality. Okay, to show that, we're going to have to use the discriminant. Discriminant being b squared minus 4ac. We also then have to remember, so if it's got no real roots, it's less than 0. If it's got one root, which is a tangent, is equal to 0. And if it's got two real roots, it is greater than 0. Well, this one has no real roots, so it is less than 0. That looks too much like a C. So less than 0. I know you might be thinking, wait now, it says there, show that inequality. That inequality is different the other way around. I know. Don't worry about it. We'll sort of show by the end of it that it does flip around. Okay. Expanding this, we have 3kx squared plus 8kx plus 9k equals 2 minus 6x. We need to get everything on one side and it put equal to 0 before we can use the discriminant. So we need to collect all the like terms. So we have 3kx squared plus 8kx. That's going to be a plus 6x plus 9k minus 2. I then like to put in brackets, especially the sort of the more complex part. Keeping together our A, which is 3k, our B, which is 8k plus 6, and then our C, which is 9k minus 2. Remembering, obviously, with the discriminant, those different values. So if we put, again, green, this is our A, this is our B, and this is our C. When we come to use the discriminant, we have B squared, so that's going to be 8k plus 6 all squared minus 4 times 3k times 9k minus 2, and yes, I'm putting it as less than 0 because it hasn't got any real roots. Expanding gives us 64k squared, let's square the first, plus 36, square the last, twice the product is double 48, 40, 80, 96k. Okay, and then this is minus 12k, 9k minus 2. I'd like to sort of do it in one go. 64k squared plus 96k plus 36 minus just so then this will simplify to 12 times 9 would give us the minus 108k, and then we've got minus minus, that's going to be plus, that's 108k squared, and that would give me plus 24. Okay, and that's again less than 0. Tidying all of this up would give me minus 44k squared plus 120k plus 36. Again, that is less than 0. However, I'm dividing everything by minus 4 to make it easier on myself, and plus I prefer to factorize when the k squared is positive. In doing so, if you remember from sort of GCSE, when you divide an inequality by a minus sign, the inequality actually flips. So then it is 11k squared plus minus 30k, and that would also be minus 9, which is greater than, or which is greater than 0. Which is also If you think about it, look at the top there, shows that inequality satisfies. Now we have to sort of find the range of possible values for k. In doing so, we need to find the critical values. Again, the critical values could be found via factorizing, or it could be found via the quadratic formula. Now I've got 11k squared minus 30k minus 9 equals 0. I'm not too concerned about the inequality at this stage. I just want the critical values. Equal 0. 11k is a prime number. Then it's going to be 3 and 3 again. I need it to be a minus and a plus. So 11k plus 3 equals 0. K minus 3 equals 0. K equals 3. 11k equals minus 3. K equals minus 3 over 11. A quick diagram will show that it's like so. And now we look at the inequality. The inequality is shown it's greater than, so it's this arm and this arm are the factors that I want. So how you would write that is k must be less than minus 3 over 11, or k is greater than 3. And hence you've done your answer. It's a 4 marker, it's always a 4 marker. You get 2 marks for finding the critical values, so minus 3 over 11 and 3. And then you got 2 marks for correctly sort of telling me the range of values. If I'd have put and instead of a comma, I'd have lost a mark. If I'd have put equal to, I'd have lost a mark. So be very careful. I'm going to do 1 more of those. As I said, with the other circle work, I will put up the answers to go with it. I just didn't realize it was taking so long, and I wanted to get onto this one. Okay, so find the set of values for k for which the equation. Well, we know what we're doing. This time it has 2 distinct roots. If it had 2 distinct real roots, if it just said has real roots, we would put it greater than or equal to. But because it's got 2 of them, then it is b squared minus 4ac greater than 0. Exactly the same thing. We're expanding it, so it's x squared plus 2x plus 11 equals 2kx minus k. We now need to put it equal to 0, so it's x squared plus 2x minus 2kx plus 11 plus k equal to 0. Just making sure. So then it is x squared plus 2x minus 2k x plus, and then going to put 11 0 in the bracket as well. So again, this is, here is my a, which is equal to 1, my b, which is 2 minus 2k, and then my c, which is 11 plus k. Perfect. B squared, 2 minus 2k all squared minus 4 times 1 times 11 plus k, brackets, and that is greater than 0. Square these, so it is 4, twice the product, so it's going to be minus 4 minus 8k plus 4k squared. And this one is minus 4 times 11 is 44, minus 4 times k is minus 4k, greater than 0. Tidy it up, we get 4k squared minus 12k minus 40, greater than 0. This is a marker. I'm dividing everything by 4 because, again, I want that sort of simplification of the quadratic, so it helps me do it. Then I got k squared minus 3k minus 10 is greater than 0. K and k, 10 is 2 and 5. There's 5, there's 2. That one needs to be a minus, that one needs to be a plus. As I said, I'm just concerned about the critical values. K plus 2 equals 0. K minus 5 is equal to 0. K equals minus 2. K equals 5. Again, a diagram just for you. And because it's greater than, I want these values here. Minus 2, minus 5. So k is less than -2, or k is greater than 5. Just being aware of time we sort of finished, so I'm going to end this now, and you can see me next week where I'll be covering logarithms. Thank you for